streaming. Hello everybody. So continuing work on my game today. So here is my game harness set up with my 4 client simulated client apps, well, in browser client apps, and then the presenter is here. This is a word finding game. So as players can look around for places to spell words in their clients. They can, let's see if I can find a word. I think laze is a word. Even lazes. Okay, so now we have this word here. Okay, so here's the deal with word finding games. If you are not a native English speaker, or you are a very young English speaker, or maybe just someone who hasn't spent a lot of time thinking about spelling, or maybe not a very good speller, it can be unfun to play games like this because other people can have like an order of magnitude advantage over you. So I want to add a capability for hints in this game so that when a user comes in and they click a letter, the game will tell them all the possible words that they could create starting from that letter. And that should, and we can scale that. We can show that information in windows or over time so that it doesn't give them immediate superpowers. But right now I want to code like the maximum superpower, and then we can scale it back. So the maximum superpower is I click on this R and immediately it gives me a list of all of the words that are legal for me to spell from that point, so that I can pick the longest word and have the greatest advantage in the game. So that's what we're going to do today, is we're going to implement this feature. So it's going to involve an algorithm to find the words, and then setting up the communication between the client and the server that this is happening, because what I do not want to have happen is I don't want the clients could very well do this work, but the word list is big, even compressed. It's like a megabyte of data to pull down, and then it's got to uncompress it, and it's like putting extra work on the clients to think about the business logic of the larger game as a whole. And so there's so those are all reasons that I don't want to put this on the client. And so the way it's going to work is the client is, as soon as I click a letter, the client's going to send a message to the server saying first letter was clicked, and the server is going to do the calculation for what words can be done, and then send back a little message to the client with a list of available words. And that's just going to be on the first letter, because any remaining letters should definitely be like, they'll be in that tree of words. Okay. So let's just start this out by having the client send a message to the server when they click on a letter. So I'll make this go away. Hello, VS Code. All right, I like to kind of close everything up when I'm starting a fresh coding job. I don't know, I've like, my desktop and my stuff gets messy, and I just have to, for my brain, clear things off whenever I start a new thing. So we need the client to send a message. So let's find our game code. That's in the front end. Source, games, Lexible. That's where we are. Okay, so in the views and the models. All right. It's going to be in the model, of course, because that's where we know that we have selected. That's where we handle all the business logic. So the selection is going to come from the UI code, but eventually it'll get into the business logic. And we'll see here in the client code somewhere we're subscribing to this select, there's a onSelect event in the block. So if I come in here to the block, we'll see that when I'm selected, letter score select map. So when the select map changes, so yeah, we want to select for player. It wasn't just I was remembering that originally I implemented select as a Boolean, but since we want to know which players have selected the block, it got a little more complicated. So you see here we call this .onSelected. So going back to the client model code, we just want to look for onSelected. Here's where we set it. So we're setting the block handlers onSelected. So we want, all right, so this is where we're going to do it. Here is where we're selecting the block. If the letter chain is just one block long, we want to then send a message. And the reason I paused my thinking there is the block selection chain can change. So I could be selecting stuff like this, but then I could go back and select the E and it selects down to the R again. So we only want this to happen if we come into this, if we come into this and we started out with 0 selected and we select 1, then we know we're good. So if this letter chain length is equal to 0, then we want to send message, send to it's this session send message to presenter, and we need to know what we're going to send. So let's look at our messages and see what we have already in our message toolbox. We have an end of round message. Oh, I think what we're going to be doing is a player. Oh, it looks like we already do have a letter select. Interesting. We already have a letter select message. So this could be letter selection data. And so in here, we have the coordinates of the letter. We have the player ID, the selected value, and then we'll just add here an is first. So we already have something there. So we'll do it a little differently than I thought. So this is just going to be Boolean. So if it's the first letter, the server is going to know it needs to send something back. So this is going to complain because first of all, this code shouldn't be there. It's going to complain because we don't have that is first in here. Now, this is, I don't know if you've been following me there, I've been changing up how I do messages. So TypeScript is more of a helper, and this is exactly the kind of stuff that I like TypeScript to help me with. So before, if I was changing the structure of this, I had at some point in constructing these message things, I was passing an any as the payload, and that broke the TypeScript chain. So I restructured these classes so that the payload can be typed. So now when I change the payload, the code where I'm using it changes too. So that TypeScript helps me fix the code that I need to fix. So we need here this additional value, which is called is first. And so what I'll do is I'll just add is first like that. And it's in here. So I just say is first is equal to false. Const, let's try again. Is first is equal to false. Okay. So now in here, if the letter chain is 0 and we're selecting something, then that is the case where is first is true. And I can't do that because it's a const, so we'll change it to a let. Else, we're just making, wait. Yeah, this is unselecting send action. Okay. If there's no selected value, I forgot what I was doing here. It's still needing blocks. On selected. Player ID. Where does this block come from? Oh, yeah, we know the block. So it's unselecting it. Okay, all right. I was confused. I couldn't remember why I had put this code here. Okay, now I know what's going on. Yeah, if there's no selected value, then like basically, yeah, we're not. What is a selected value? It is a Boolean. So if we're selecting it, let's change the name of that. That's confusing. F2 is selected. Boom. Now that is clear. That's clear. Yeah. So. Yeah, so if it's selected, then we're going to do this. If it's not selected, we need to find it and remove it from the chain. That's what was confusing. Okay, now we've got is first in there. Now that's going to the server. So now let's put a little code in the server side so that we can just see that we got that. So this message is a player action, and the player action we want is letter select. So let's find that here in the presenter model. Letter select down. Let's find dot letter select. There we go. So if we're selecting a letter, we want to go to this function, handle letter select. Here we'll just say if data.is first. We're going to be doing some stuff, so I'll just say console.log first selection for some player is some letter, and we'll come in here and we'll just say player ID, and the letter is data dot coordinates. So we'll put this up here to get the block, and we'll just block dot selected block dot letter. So that should tell us whether we're doing it right. Okay, refresh. So by the way, I'll just say the reason that the refresh brings us back to a state that we can use is that I save game state, and so when the game reloads, it pulls the state from I save it in the database that's available on the web client. And in fact, I'll just show that to you right now. So if we hit F12 on this to bring up the dev tools, you can come in here to application, and then let me make this bigger so you can see what I'm doing. So in the application menu, there's the storage. I'm using the IndexedDB because I just have written code for it. It's really big. You can store all kinds of data there. I think it's I don't see any cons for using it other than it's a little tricky to code. And I just lied to you. I just totally lied to you. I use IndexedDB and other apps, but for this one I've been using session storage because I don't want to. I want this to be stored per session, not per. Like if you store it in IndexedDB, it'll live across all instances of your browsers, which is not exactly what you want because I want to be able to use different browsers to play different games. So that's why I picked session storage. Sorry, I lied to you back there. All right, so here in the localhost 3000, we can see how I store this data. So each client, there's a lobby state and a game state, and that's just stored as JSON in here. And so if like we look at the presenter game state, let's see, yeah, you can see, can I scroll through this? Dude, yeah, there's a whole bunch of stuff there. I store it in JSON because it's simple. It's easy to reconstitute it. And this is, you might notice that the text here is kind of small. I actually have, it's my own special JSON a bit because I have my own serializer that's meant to handle circular references, and also adds extra information to help with reconstructing types. But it's essentially JSON. I mean, a regular JSON reader could read it, but it would come up with the data that comes back would look a little nonsensical because it has these extra types, and you need to have the special code to reconstruct it properly. Long story short, refreshing doesn't make me lose my place because I save my game state as the game is going along. Okay, that was fun. All right, now let's see if that works because I want to look at the console, and I'll just clear the console. So we'll start fresh. Okay, so here I've already selected something. So if I do the E, and nothing's going on. So let's deselect everything, select the N. There we go. First selection from client 1 is N. If I go over here, first selection from client 0 is L. Great. So that's working. If I deselect it, it doesn't redo that message. If I select again, it does, but more letters does not. Okay, so that's working. So first mission accomplished, we've sent the message to the presenter. So now in the presenter, find first selection. Okay, so here is where we want to do the find word code. So let's just code by intent here, and we'll say word list is equal to find words, and we're just going to pass in the selected block. Okay, and then we are going to say we want to print the word list. So we'll just say console.log found these words, and we'll just say do a new line 1 2 3 4 word list dot join a new line 1 2 3 4. Okay, that'll give us a nice indented list of words in the console. Now we need to find the words, so let's do find words, and we're going to take a block, or we'll call this the start block, and we're going to pass in a block model, I think, letter block model. All right, and then we're just going to return, let's say, const output string array is equal to an empty string array, and we're going to return output. And just for fun, we'll put some words in there just to see it work. Refresh because we broke something. No, find this dot find words, and let's just go ahead and put a header on that guy because I think they're pretty. They make it easy on the eyes. Look at that. Look how easy it is to see where functions begin and end. I love that. Okay, so find words, da 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 da. Let's test it. Okay, come in here, deselect it all, reselect. Oh, crap. Find words is not defined. What? Let's save, refresh, try again. Yeah, there we go. See, this is weird. Sometimes when you compile, it doesn't remember what you did. But there it goes. So yeah, so that's working. All right, so now we need to actually find the words. Let's talk about the algorithm. I like to think about my algorithms fully before I try to implement them. It just makes it easier. Here's the last algorithm we were playing with. So this is such a useful thing. I think I'll just keep using that grid. And I'm going to draw on a different color, and let's erase stuff. You go away. All right. And I'll erase a bit here. Okay. We can write it here. All right. So back to. Okay. So let's just put some letters here. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, whatever. Okay, so let's say we start our selection here. The way this algorithm is going to work is it's going to have a list of words, and it's going to figure out, well, what are all the words that begin with A? And then we want to then look at all the potential neighboring letters and explore each one at a time. So we'll probably do it just like a grid, -1, 0, 1 on the X, -1, 0, 1 on the Y, and we'll start here. And then we'll ask, is AI a word? Are there any words that begin with AI? And there probably will, because like ailment is a AI beginning word. But then when we'll have some more letters up here. So we might have Z, T, F, Q here. And so when we're coming up and we're checking this I, we'll keep recursing, and we'll check this T, and we'll go, oh, that's not a word, AIT. There's no word that begins with AIT. And so then it'll go to AIF, and it'll say, oh, nope, there's nothing there. AIJ, nope. And then AI, what even letter is that? 2. I don't know what I wrote there. That's not a word. AIB, there's no word that begins with AIB. AIQ, nope. AIH, I don't know, maybe. But the whole point is we'll eventually get back here and we'll give up on AI because there's nothing else there. Then we'll come to AB. So, all right, so that's the first part of our algorithm. So that's how we're going to search this tree, and we'll always check. We'll have to keep a set of select. As we move down the tree, we need to remember what letters are selected in our set. So we'll be keeping a track of the selections, and then the last thing is to keep track of, to know that I've got implemented here, is the way that I keep my word list. So my word list is actually kept as a tree. So the root of the tree looks like this. There are each node in the tree has a list of terminating letters. So we'll call this the TL list, terminating letters list, and the very first node in the tree isn't going to have any, because I only have 3-letter words or more, so there's going to be no terminating letters. But then there will be children. I need to draw this bigger. So it'll have children. And the children are going to be more lists, and they're going to be under A, B, C, D, E, F, G, So this is going to be, since this is the root, this will be the first letter. So A will lead to another list of words that all begin with A. And so then that will also have a list of children, A, B, C, D, E, F. and it'll have a list of terminators, but there won't be any terminators because at this point, this node in the tree represents 2-letter words. So the A, and then if there's a list here A, this would be a list of words that begin with A, like aardvark would be in this list. And then this B would be a list of words that begin with A, B. And so abacus would be found in this node of the tree. So this tree just keeps on going until so let's do abs, the word abs. So B would lead to another node in the tree, and in its terminator list it would have the letter S. It would also have A, B, C, somewhere down here S, because there would be a list for S because abs is a word, but also absolute is a word. So you'd have to keep following this tree down to get absolute. The reason I constructed this way is I knew eventually I would be doing algorithms like this. And if the tree is constructed letter by letter, then these letter by letter algorithms where I'm searching around the tree are going to be easier to implement because I can just pass where I am in the tree as I'm searching these algorithms. It makes it really simple. That's not the only way to do it. Like, as I'm thinking about it now, um, you could do just like searching around. Actually, no, this does make it a lot simpler because think of if you didn't have this tree, think of like how difficult it would be if you're looking at, A, B, L. Okay. ABL is not a word. You're not going to find it in the list. But there are words that begin with ABL, like ablate. So you need to have a list that will tell you whether the word is there and also tell you all of the words that begin with ABL. And if you just have a plain list, even if it's a hashed list that's easy to look up, it's hard to look up all the words that begin with ABL. That's an order n operation. And it actually starts to look n squared because you have to repeat it as you keep going down the list and getting longer and longer words. You've got to keep searching the list. And anytime you search a list straight up, it's n. And if you're doing it as you're going along words, it tends to n squared. So that's terrible. This is closer. This is more like n. This is more like n log n. Like these searches make it simpler. So it's going to cost, just basically the number of letters that we are exploring. So this is not too bad. All right, so now let's think coding wise, what is this going to look like? So let's make this a little smaller and move it over so we can write some code over here. Just some pseudo code. Okay. All right. Huh. All right, I've never tried this on the whiteboard, so let's see if I can do this. I want to drag this. What if I want to type over here? Come on, whiteboard. I'm so just. Oh. Okay, I guess I can do it that way. Fine. Typing. Okay. All right. So for each letter, okay. Tab doesn't work. I can't space. Are you kidding me? Okay, so, all right, so let's just go 1, 2, 3, 4. All right, so for each letter, yeah, I already don't like this. I'm just going to, since I'm going to be typing in pseudocode anyway, I'm just going to type it as comments inside my regular code. All right, so find words, let's clear out that. So let's pseudocode this. Okay, for each letter. Okay. Is current letter on a word? Yes, means we remember the word. Okay. No, we're to skip it. Actually, I don't even going to mention that. Okay, then we want to start loop through neighbors. Okay, so we want -1 to 1 and -1 to 1. Okay, so we do need to say, is this a valid choice? And on that one, we just say no, then continue. So a valid choice would be off-grid, so it should be on-grid, not selected. So it's a word that's on the grid that we haven't selected. Okay, is it on a word? Have we formed a word so far? Yeah. Have we formed a word? Yes, then remember it. Then loop through the neighbors. And and so we recurse. Loop through the neighbors, and we'll just say add to work. Oh, actually, yeah. So I'm going to say this: add neighbors to work list, because I'm going to do that again. I'm not going to recurse here. I'm going to do recursion-like coding, but it's iterative inside the same method, because I don't like to. I like to have my stacks explicit. I don't like to have the call stack implement my stack for me. It is kind of pretty and elegant, but it's also a little slower, I think. Maybe I'm wrong. Let me know if I'm wrong, but I don't think I'm wrong there. Okay, that's kind of easy. Is that it? This is going to get trickier as we figure out the letters, but that's okay. All right, so let's start by creating a work list. The work list is equal to an array that has the start block in it. Okay, and now we're going to say while work list.length is greater than 0. So while we have something to do, let's do this stuff. So for each letter, we need to see if the choice is valid. So so when you say const block is equal to the work list dot pop. If block dot coordinates dot x is less than 0, or block, again, I like to put these ors at the beginning of the line. It's easier to see what's going on. Coordinates dot x is greater than or equal to. You know, some people might just put equal to because you're just looking for it to hit the edge, but I always put a greater than because I feel like it stops bugs in some cases where you you wouldn't want to maybe you accidentally added 2 or something, and you're never thinking that that could be a possibility. If you just put equals, it won't always catch those out of bounds. This dot board size dot x. So if x is equal to the board size x or bigger, we're off the grid. Then we want to say block.coordinates.y is less than 0, or block.coordinates.y y is greater than or equal to this dot board size dot y. Okay, if any of those are true, we are off the board. And I'll just put these here, line them up so it's pretty. We'll just say continue. Continue. Okay, so do. So ignore blocks off the board. Okay. Our other condition is if it's been selected. So we need to have a selected list. Const selected blocks is equal to a set of type number is equal to a new set of type number. No, come on, Eric. Come on, you can do it. My HTML helper likes to add that junk there for generic types. All right, so we have selected blocks. There's nothing selected. All right, so, we might as well just add an or here. Or selected blocks dot has block dot ID. So if it's selected, we're done. Blocks off the board or selected blocks. And this, I'm trying to think if this is a faster check. Usually it's good to put your faster checks at the beginning of an or so you don't force a computer to do all these other checks. I don't know, I don't feel like I don't care enough. I don't think it's going to be a big deal. All right, so we want to ignore these blocks. There's another one here that I don't know if we want to do yet. I'll just put it here, fix me. And I don't know where I'm going to do it yet, so I'm going to put it up here. So I'm just put a fix me as a reminder. Actually, yeah. What about words that we can't spell because of score? All right, so that's trickier to do that because, so like here, we have, these words are scored, these letters are scored because I created a 5-letter word to capture these letters. That means the next person coming in, they can't just do like hen. They can't just go, oops. Like yellow can't come in here and then say H-E-N because H-E-N is only a 3-letter word and I can't submit a 3-letter word. So this is going to have to, I have a feeling I'm going to have to account for that in this so that I don't confuse players. But maybe I'll leave it. I'm not sure if I want to do that because I think even if you have a superpower, you should have to do some work in your brain to know if you can find that word and make it work. Okay, so back to here. So we did this first part, and now we want to see, did we form a word? So we want to have some kind of a node. We'll call it the current word. Current word spot is equal to this dot word map or the word tree. There we go. So the current word spot is the word tree. And let's just make this simple. So we're going to say output dot push dot 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 current word spot dot words. That's it. And now we need to add the neighbors. I'll come back and fix that, don't worry. For x, let x is equal to -1. X is less than or equal to 1. X plus plus. Do. And then we have the same thing for y. Y, y, y. So we're gonna add. We're gonna, I guess the left side, then the middle, then the right side, top to bottom. Okay, and then we want to say, oh, and we want to select here. Yeah, so we push out the words, and so we're going to say selected blocks dot add block dot id. So now the block is selected. We're just going to put them. We're just going to add them. We're going to say work list dot add, or no, push this dot get this dot board. Wait, how did we get the blocks? How do I get the block based on coordinates? Is it grid? The grid. This dot the grid. Get block. The block. We need a vector, so we need a vector of an x. Yeah, let's set it over here. Const neighbor spot is equal to a thing that has an x and a y. The x comes from the block.coordinates.x. Yeah, this is where a real vector2 would come in handy. Because then I could just add the vectors. I could make a 2 vector. I'm so tempted to code this. Okay, I'll code it. Neighbor spot is equal to a new vector2 xy plus this plus block dot coordinates. Boom. So that's the neighbor spot. So we're going to get the block at the neighbor spot. Okay, I got a bunch of, I've been coding by intent for a little while. Now it's time to pay the bills. All right, so let's first fix this problem with vector2. Cannot find it. What? Vector2. That's the vector2 we want. All right, so on the vector2, we need to have a constructor that takes an x number, y number, and sets this dot x is equal to x, this dot y is equal to y. Constructor. It's no longer an interface, it's a class. I hope that doesn't break the other code. And then we want to have, can I do okay, this is what I don't know. If I've never tried this in TypeScript. So TypeScript operator overloading. guess the answer is no. No operator overloading. Sad, but we'll live with it. Add a vector2. So add this, and it is going to be a vector2. So it is going to return a new vector2 where the x is add this dot x plus this dot x. Oops. This dot x, comma, add this dot y plus this dot y. That's it. Okay. Yeah, I think I broke a bunch of stuff. Okay, anyway, we'll see what happens. All right, compiler, what do I need to do next? So I'm back in the presenter. Doesn't like this, but I can fix it now. Boom. I can't do that, but I can do this. Block coordinates, so that's our new vector. What? Go to definition, block coordinates. Aha! Aha! It's a vector2. I'm gonna add that. Yep. Coordinates is a vector2. Vector2. And it's not gonna like that, so it is a new vector2. I'm gonna have to fix a bunch of stuff, but this is why I didn't want to do it. But now that I'm in it, I'm not gonna stop. Okay. Back to the presenter model. Hey, that worked. Okay, now we need the words. So go to definition. The current word spot is this the word tree. Go to definition here. Go to definition here. Okay, so now we need a getter. Get. See, there's our terminators and branches. Very simple. Get words. It is a little function here, and we'll just say output const output is equal to as a string array, which is equal to a nothing. Okay. And we say the root is equal to get root is equal to the root word, which I will also this dot root word like that, and then I'm going to say I don't even need output. I'm just going to say this dot, I'm going to return this dot terminators dot map t is the root plus t. That's it. Okay, now we need a root word, which is another getter. Get root word, and yeah, okay. So root word is going to be return this dot letter plus parent this dot parent dot this dot parent dot root word. Okay, here we are recursing. And it's saying you don't have a letter and you don't have a parent. Fine. So here, but this is gonna be easy to add. This is gonna be so easy to add. Words for each, we just say add. And so add is where we're doing this stuff. So we have here my letter, which is a string, and we have a parent, which is a word tree. And we may not have a parent, so we'll just do that. And just to make sure that it isn't doing something weird. I think undefined will work, but if it is undefined, I just want to make sure we have that. And this is not happy because return. Okay, there we go. Root word. It does not have an annotation. Is a string. Okay. So we need to set the letter and the parent. All right, so if the word length is 1, we push the terminators and return. So we're going to add a word. Yes, so where do we create a new word tree? Here. So the constructor for word tree needs to take a letter, which is a string, and a parent, which is a word tree. And we just say this dot letter is equal to the letter, and this parent is equal to the parent. Okay, there we are. Now, okay, so this is going to fail because on the create, the output is going to have no letter. That's right. So you're just going to have nothing for a letter and undefined for a word tree. That makes sense. Now, when we're making a new word tree, the index is a string. Yeah, so that's the index. That's if, since I didn't know what it is a sign that I should change my name. So this is the index letter, the index letter. If we don't have an index letter, then we're going to make a new branch. So that new word tree, its letter is the index letter. And what tree are we on now? We're on me, so we just put in this. Okay, so that's the parent, that's the letter I'm at. Okay, so now we've done the setting. Okay, so now we can properly get the words. Good. Okay, back to the presenter model. So the presenter model is still complaining somewhere, and let's figure that out. Probably because of the Vector2 garbage. All right, F8, what's our next problem? Yeah, you can't do the Vector2 there. So let's do a get the grid block. Okay. Fine. New vector 2 start x, y, like that. There we go. Vectore, that's Spanish, I guess. Then same thing here. Doop, doop. We don't need the x in there, but we need to change that. And we paste there, paste there. Whoa, careful there, Eric. You reversed something there, and it's tricky. Gonna introduce a bug if you're not careful. X comma y minus 1. Okay, and again, x comma y plus 1. Why did you do that? Y plus 1 and paren. X plus 1. X minus 1, x plus 1, x. Okay, that looks okay. Alright, no more searching. Alright, presenter model is happy. Okay. Oh my gosh, did we do it? Did we actually get this? So, dot words. There we are. Okay, so we did the find words, did the work list. Oh my gosh, I can't believe this is. Okay, if this works, I am going to be flabbergasted. It won't work. It's never works. Never works on the first try. Don't even think about it. Refresh. Yeah, see what I mean? We still have stuff to compile here. Fix that. All right, F8. My vector2 broke something else. I knew it. New letter block model with the letter deck, and then this new vector2 blah blah. All right, did I break it anywhere else? Nope, I don't see it. Saving. But it still thinks it's broken. Okay. F8. Do I just need to save it again and make you shut up? Yes. Line 10 in speech helper. Fine. Line 10 here. You just wanted an extra equals. I'll make you happy. Hey, we're back. Okay. Here we go. I knew it. Not surprised. Not surprised. Okay. So this happened in letter grid model called from Flexible Presenter line 380. We're going to push the neighbor spot. Oh, stupid. Okay, I had this check here, but guess what? Get block probably already has that check. Yes. So, okay, fine. Let's do it like this. Const neighbor block is equal to the grid.get block neighbor spot. Okay. And I know I'm still missing something, but we'll figure it out. We're gonna push the the work list is an actual block, so we're just going to push the neighbor block on there. So if neighbor block, if neighbor block, then we'll push it. That means we don't need this check anymore because it's impossible to push on a block that doesn't exist. I like it. I like it. Reusing code. Okay. Okay. All right. This is still going to break. I mean, because I don't think we fixed this particular issue. Refresh. Okay. Select the M. Yeah, everything is unhappy there. Holy moly. Holy cow, we really blew that one out of the water. Okay, we have a mistake. Okay, what's going on? Oh. All right. So let's just figure out what's happening here. Go to definition. Console.log checking spot spot.x spot.y, and you know what? This is almost a situation where I feel like I need to run the debugger. Clear. Okay, control home. Yeah, I'm just gonna run the debugger because this is a pain to figure out. So let's go back to the presenter model and let's just watch what's happening starting here. I have a feeling I'm just like doing something weird with the ad. And I am selecting blocks. Oh, I know what's happening. This is still a problem, but I know how to like stop the proliferation. Words here is equal to, oh no, I've hit a weird problem. Okay. Yes. Yes. Okay. Okay. Yeah, I'm not properly recursing down the tree, and there's a condition I need to check. So we can't just we can't use an empty word list as a terminator because there could be an empty word list, but there's still words to go. What we need to do is, if there's no more words, we're going to continue. So we're going to say if we're at the last possible letter ever, we should not go any further. So if the current word spot dot, and these are all private, so let's just go to, these are branches. Let's go to the definition here. These should all be private. I marked them that way with the underscore, so just that was too lazy to type. Okay, and we want to have a getter for a last letter. So we're going to say get last letter returns this dot branches, dot size 0. So So it's the last letter if there's nothing else to check. Okay. So back to the presenter model. Yeah, I knew it was this too simple. So we're going to do there. So if it's the last letter, we're going to continue. Nothing, no more work to do here. Okay, then, yeah, if it's the last letter, we're not going to check anymore. But we do need to keep checking because even though currently we might not be in a word, we may eventually end up on a word. So we have to check them all. But we don't need to go forward with the current letter if that branch doesn't exist. Yeah. So this is another quick terminating condition. If the selected block has the block ID, yeah, so if it's selected, okay, or not current word spot dot has branch block. Yeah, and something else that's going to throw us off here is QU. That's going to blow us up. But let's just go. Let's go. If you don't have the branch block dot letter, if you don't have that branch, and I might as well just do this because QU is going to be in there. Some blocks have QU as letter. If you don't have that branch, sorry. I'm sad because this was not as easy as I was hoping there just for a second. Has branch. I need to code that on the block model. So where are you, letter block model? There you are. So has branch. No. Yes. Letter block model. Where are you? Here. Yes. No, that's not what I want. Dang it. Dang it. No, it's the current word spot. Okay. So current word spot, we're checking something here. Last letter. All right. Let's go here. And let's say has branch. Has branch letter string return this dot branches dot get letter question mark true false. I want it to be a real Boolean coming back, not a branch thing. Okay, back to the presenter model. Okay, so if we've selected a block, we don't want to keep going. If there's no hope for more letters, we might as well not keep going. Okay, then let's push all the words, and if we're the last letter, there's no point in keeping going. Now we can select we can keep looking for more work. Okay. Okay, there's a problem here. For the next set of work, that set we need to also advance the word tree one letter depending on the letter that's in that set. Okay. Now my brain is getting a little befuddled, so I need to draw this out. All right, so let's look at our word tree. So let's just make it a simple word tree here. And okay, so let's say we're doing some work and our word tree starts out at the top. Oh, I can already see what I need to do. Okay, this is not bad. This is not bad. Yeah, okay, so originally you're at something, there's no letter there. And there might be like A, F, S, T, there might be something like that there. And then this is going to have some like this. And we're starting out, we're at a place where there's no letters. So on every word, we actually need to follow the word tree down one, see if there's anything there, and then follow it back. If we're continuing, we need to go backwards because we're giving up on the recursion. Yes, I think that's right. So let's think about this. So let's do A, B, C, D, E, F, G, H, I. Okay. So first we're going to look at F. So F is, we're going to clicking on F. So F is going to start our work tree. So we'll come in here and we'll find the F branch. So on the letter, we're going to say advance the branch. Okay, and do our stuff. And then we're going to add more work. So we're going to add A, D, G, B, H, C, F, I. Actually, we're going to start on E. I'll click on F. We're going to E. E. All right. So we're going to advance it. We're going to be on E. Then we're going to go to A. I can already see this is broken. We're going to go to A. And we're going to advance to, yeah. When I drop new work, I need to drop with it the spot in the tree. And the selection stuff is going to break too. But we'll go. We'll do the. So I need to drop where I am in the tree with each letter. I also need to drop what's selected. So location selected. Yeah, can't get away from this because the state of where you are down the tree matters. This is where recursion. Recursion can probably help you here. Like true recursion, because then, all right, fine. Put your money where your mouth is, Eric. Do some true recursion. Yeah, this is where recursion helps you, because now I'm thinking about like making structures to track all this stuff, and I don't want to. I want to let the stack handle it for me. It'll feel more natural. So I'm just gonna do real recursion here. All right, so, and yep. So find words. So when we recurse, we're just going to be, yeah, yep. So we're going to have an output. Okay. Yeah, okay, I want to keep track of some of these things inside, so I'm going to have the recursion happen inside a lambda in here. Okay. Okay. So we're going to call this find here is equal to some method. I don't know what the parameters are going to be yet. Okay, so we're going to call find here. So down here, so find here is going to it's going to this is where the recursion is going to happen and find here like this. And we're going to say return find here, and we're going to do find here on the start block like that. Zoop block. Yep. Okay, so find here needs to have a block, which is a string. No, it's a letter block model. So we have a block there. There's no work list. There are selected blocks, and there is, we don't need that either. Need that. But we do need the word spot here, which is a word tree. Okay, now, this is where we get to repeat our logic here. Okay, we don't need the block, we don't need to pop it. If the block is selected, or the word spot does not have a branch, we don't need has branch anymore. Go to definition. We just need branch for that letter, and we'll return it. Okay, back to the presenter model. Okay, so we're going to say, all right, so I'm just going to do this short one because I don't want to do unnecessary computation. So I'll continue here, and then I'm going to say const, let's call this the parent spot, and this is the word spot is equal to the parent spot dot branch get parent spot dot cranch. Cranch. How did I spell you like that? F2B branch. Okay. Get the branch for block dot letter 0. Okay. If there's no word spot, then obviously if not word spot. Nope. Spot, then continue. So there's no possibility of words there, then no need to go. Oh, return. Actually, we should return nothing. Return nothing. This is of type string. Oops. String array. Okay. Yeah, we don't need to push anything here. Oh yeah, we do. We need to, yes, we need an output. And we don't need it there, we need it in here. So let's do this. Return output, return output. Now we need to add the output for all of the recursings. Okay, so do we ever need to check last letter? No, because there won't be any branches. So we'll just go back. I don't need last letter. Oh, that was go to definition. We don't need last letter anymore because it would just saying if there's no more branches, but we'll get there because it won't find a branch. So we don't need to check that. But we do need to do all of this stuff for the recursing part. All right, so what's going on here is, yes, I need to select it. Yes. Yes. So this is the word spot. Okay, so we're on this word spot. If there's any words here, and we put them in our output, then we're going to recurse through all of these guys and add their output to our output before we return it to everybody else. So we are going to recurse. Yes, so we want to do the selection here, yes. So add the output, select it, now we can recurse. Okay, you bad. So we're going to select it, recurse, then we're going to deselect it. When we're done cursing, do we want to deselect it here? No, we only want to deselect it after we've marked it as selected. Okay, so we're good. Selected blocks dot remove or delete the block.id. Yes, it's feeling better. The real recursion is working better for this one because it's a little complicated. And we're going to return our output. Okay, so now here we're getting the neighbor block. We got it from the coordinates, and we did the vector2 because the block is here. So what does the recursion look like? The recursion looks like output.push ... find here the neighbor block, comma, our word spot. So we don't have to remember. These all keep passing the same word spot. We're not changing the word spot location, but the children get one down the tree because they'll advance it here by looking at the branch. And we'll push all the things here. Okay. Starting to look better. So we want to find on the start block, comma, this dot word tree. So start block, beginning of the word tree. I'm ready. I think we're gonna get, this is feeling better. Okay, refresh. Do we see any red? Nope. Okay, here we go. Unselecting M, reselecting M. Oh, we were so close. We were close. Okay, yes, now we're back to this error. Okay, why are we checking a location outside the grid? We should never get location is outside the grid, so get block is throwing like it should. That's what's happening. Go to definition, see it just printing an error. I think I had this here out of extra caution, so I'm going to remove it. Okay, and then back on the presenter, we only want to do something if there is a neighbor block. So we say if neighbor block, then we're going to do the thing, because there may not be a neighbor block. Okay. Might be it. This might be it. This might be it. Clear console. By M. Oh man, why are we? Wait, get block. Oh, it's going to be a thing where I have to save it again. Go to definition. I don't need that. Well, save, refresh, try again. Yes. Yes. But it's wrong. It's wrong. Okay, but we're close. We're close. Okay, I don't want this anymore. Okay. Back to presenter model. So close. Yeah, this is a tricky algorithm. Tricky. Refresh. Uncheck. Check. Boom. Boom, 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 boom. Okay. So it found those words. But they're only 2-letter words, so it found ma. How could it possibly find me? So it adds them left to right, up, down, MA, and then down here, and then down here. So ME should never have been found. Okay. Okay. There's a bug in here. It's probably a simple bug when I figure it out. So let's just put what block we're checking and what coordinates when we get in here. So console.log. Check. We're checking block.letter. And just put what letter the parent is at. In parentheses, because sometimes it's empty. Parent spot dot letter. Nope, nope, nope. Dot root word. And let's put the coordinates here, which is block dot coordinates. So let's go here as the vector2 issue, go to definition, and let's just add a toString. toString and return something parentheses comma bloop this dot x this dot y. Okay, that should work. I hope. Okay, back here to presenter model. Okay, let's just see where we're checking and where it's taking us. So clear console and doop, boom. Okay. Okay, yeah. Oh, bother. Fine. Dot toString. Okay. Clear. Doop. Oh, it didn't clear the console. Why didn't it do that? Clear console history. Clear console. Okay, so if I do, okay. Oh, wait. Why is it? Why is it in there twice? That's weird. Okay, so we're checking M. There's nothing in the tree. Okay, this is crazy. All right, I'm gonna just refresh because it's driving me nuts. And uncheck M. Check M. There we go. Why is it still doing object? Check. And block letter. Oh, because no. Root word. I think it's a saving issue. Can you tell I'm getting tired of this? Do. Okay. Control. Okay, well, let's just see where it's. I want to see the coordinates. Why won't? Go to definition. It's returning toString is obviously a string. Why are you not printing it? This.x, this.y. Block.coordinates.toString. I'm not convinced that that's not. Okay, I'm just gonna, just because I'm just feeling really ornery, I'm just gonna start a fresh game. Okay, and start over. Okay, back up here. I'm gonna click I. There we go. So we're checking I. At 2.2. Yep. Then we're going to check C. And then we're going to check E. And then we're going to check E again. But not really, because it's been selected. I want to see when I'm like finding words. Let's do const found words is equal to this. And we'll expand it here. And we'll just do a console.log for found words dot join. There we go. Okay, so this will show us the words that we find at particular spots. And this is the root word. Yep, and so the root word is I, the root word is CI. No! Okay, we calculated the root word wrong. The root word should be ICE. Okay, so let's do that. So that's our first bug. Root word. Where do we do that? So when we ask for the words, go to definition, it asks for the root word. The root word is the parent plus the letter. Yes. Okay. Okay, refresh. this over. Okay, quit, clear. Do that again. Do. Click start. Okay, here we go. D. Okay, this is looking good. Home. Okay, so when we're doing D, we found da D do. So D. No. No. How did we find? We need to look at the parents' words, because this is looking into the future. Yeah. Okay. So presenter model. The words that we found should not be the word spot. It should be the parent spot, because we're here. Okay. Let's just quit, clear, do it again, do. Click here to start. Okay, let's do P. Getting better, I think. All right, so we're checking P. Nothing there, of course. Now we're at PT. No. Okay. All right. That list of letters that's in the parent word, we just need to know if it is a word. Okay. Okay. So we have something like this. All right, so the word we're on is okay, we don't even need those letters, because we'll eventually I think I created this tree kind of weird. Nothing like having a plan meet reality. Okay, so the problem is that I made the tree heterogeneous. That's the problem. This tree should not really have these letters or these the terminators in them. Should not have the terminators in them. It should know if it is a terminator. So no terminators. And that is terminator. We'll just set it equal to false. And in the constructor, we just need to say whether it's a terminator. It is terminator. It's a Boolean. And then we'll just say this dot is terminator is equal to is terminator, and then we're going to have another word. We're going to say get dot is word. So we're going to say get dot word. It's my word. We'll call this my word. And this is going to say if, let's see, return this dot is terminator. If it's a terminator, it's going to return this dot root word plus it's going to return this dot root word. Otherwise, it's going to return undefined. Okay, and now we need to construct it differently. There is going to be no words on here. It's just going to be one at a time. One at a time. There are no words to be loaded here. It's just whether I'm a thing. And so when we create it, it needs to have a new word tree as terminator false. Then we'll add it, and then the add, we don't care about the word length, but we will pass it here. Oh. Okay, so we're adding it. If the word length is equal to 1, this dot terminator is equal to true. Return. No, we're not returning. Oh yeah. We created a branch for A, and if it's 1, new word tree. And we're getting the substrings. I feel like I'm doing this wrong. False. In fact, I don't even think I need to set this. I don't need to set that in the constructor because this terminator should just be false until I tell it it's not. Okay. All right. So here we're adding a word. So if let's say we add the letter A. We come in here. Word length is 1. Word length is 0. It is a terminator. Yep, that's what we want. So the words that end will go here. We'll do the new word tree, and we'll get it and add a blank word, and we'll mark it as a terminator. Okay, there we go. Now in the presenter model, the word is equal to word spot dot word, my word. Yes. If word, we're going to push it there. Now we're going to say it will also indicate we found a word. It's our console.log. Found word. Excellent. push word rate. Okay, now we select me, and we are going to do this. Yes. Okay, let's try again, folks. You're not happy with that. If word, then what are you happy about? Cannot find name, find words. Did you not save it right? Yeah. Okay. Quit, clear all, start over, tink, tink, play. Okay, here we go. H. Checking H. And we're checking the O. Found ho. That's right. Found hod. Hods. And checked a bunch of letters around the S. And then we found hop. And we're hopey. Okay, hope, soaped. H-O-P-E-D. Yep. Looks like it's working. Looks like it's working. That's good. And then, okay, so we're doing a gazillion checks. Holy cow, we are doing tons of checks. Let's do a little perf on this. Let's just do like a start. Actually, we'll do it further outside. So let's get rid of this check code here, and let's get rid of this found word console log. There we go. There we go. There we go. All right. So now this find words, who's calling it here. So we're going to say const start time is date now, and then we'll say const end time is equal to date now, and then we'll say found word list dot length words in some number of seconds, which is going to be the end time minus elapsed end time minus start time divided by let's add another parentheses here. Divided by 1,000 dot to fixed, just 2 decimal places, and then there we go. Seconds. Save. And I gotta go do this all over again. Quit, clear, do. Okay, here we go. B. And found 65 words. Oh, it's fast. Super fast. Like, not even noticeable. Okay. Let's get rid of, and this, and all right. And so we don't want 2-letter words. Sorry, we don't want 2-letter words. So let's go here in our word finder, and we'll say if word dot length is greater than or equal to 3, then push it. Okay, and then it has all these things and so many words I don't even know these words. Look at that bed cover. Would you ever find that? Unless you're a master speller. Okay, nice. And for fun, let's sort the word list. We'll go const output is find here, and then actually, no, we'll do it like this. Return output dot find here. Can I sort it? Sort AB is b.length minus a.length. I think that should be a, give us the long words first. Boom. And come back here, quit, cleared. Alrighty, play. Okay, and then let's do it. H. Length. Where did I do that? That was on 370. If word dot length. All right, clear. Kind of annoyed by how much I have to move that around. Okay, here we go. C. Beautiful. 42 words, and they all look right. So let's see if we can find, like, Celestines. C. Okay, C, E, L, E, S. Oh my gosh, such a big word. T, I, N, E, S. Holy cow, that's such a big word. Holy cow. Celestines. Never would find that in a real game. That's such a huge word. Okay. All right. So we did the hardest part. That was the hardest part, is figuring that out. And some of these are going to just have crazy go nuts words. Let's see if we can find one that looks like it's going to be a lot. Oh, this is broken here. Q. Yes, that is not interesting. There are a few keywords that begin with pure Q that are not going to make it here, but that's fine. Okay, now we got to fix the QU part. Okay, so let's check in what we got, because I feel like it's pretty good first, and then we'll do the QU. All right, make this a little smaller so I can see what I'm doing. Looking for turds. Okay, that's a good change. Speech helper. Oh, yeah, that was a stupid little change. Word tree. Yeah, that was a major refactor. Flexible presenter model. We added defined words. And, okay, I think we'll just keep that there. We'll get rid of it later. And this changed because of Vector2. There's actually a couple of changes in here. It's kind of dirty. Is first. Yes, that's important. And then we got the new Vector2 stuff, more Vector2 stuff, and then changing stuff in the to-do. All right, so we did this. We pinged the server, and the server is calculating available words, but we need to fix this. So added word finder on the server. Boom. I should have prefixed that with flexible. Okay. QU. You're not working. You're not working QU, so let's fix it. Okay. Find words. All right, so the find words. We need to do something special for the case of QU. We actually need to advance it 2 times. So here, Yes. Okay. So we just need to do this is simple. For let I plus plus, or no, I is less than block dot letter dot length I plus plus, and then we are going to get the branches on each on the things. So do I use parent spot in any other place? Let's just do here let word spot equal to parent spot, and then we'll say word spot is equal to word spot dot branch the block letter I. So we're going to branch forward to QU. That should work. So yes. Yes. Question mark here. Because we might not get a word. I don't know. Might not get a word. Okay, let's try it. Could not restore game. Oh, because it doesn't know what a vector2 is. Well, let's fix that. So the flexible presenter model up here. This is part of my serialization stuff. I have to tell it how to construct these things. So there's vector2s in there. Vector2 is a new vector2. And then 0, 0. There we go. And then I need to do the same thing on the client side. Yeah. Because there's no true discovery of types inside the namespace, I have to do my own type discovery system. That's exactly what this is. That's how I can. It's a little unwieldy, but works pretty nicely actually. Okay, so we're playing the game. So let's come in here and let's find our QU here. Q. Nothing. Probably good. Let's find another QU that might be in a better spot. Where's our QUs? Come on, QU. There was that one with the that was about to do a queen. Here we go. Do QU. No words. Okay. Let's do R. Oh, I think I need to clear everything and start over. Quit. Okay. Finding a Q. First of all, let's just spell a word. R-I-D. That will save the state for everybody. But now we'll find a Q. Oh, there was one. Q. Found 0 words. Oop. P. Did it find any? Is there a QU word here? Q-U-E-U-E, no. Q-U-I-E-T. Quiet should have been on there. Okay, so that was a failure. Why didn't it find quiet? So on the presenter model, let's see what's going on. Find words. All right, so we're going to come in here and we're going to get a QU. So the word spot is going to branch forward to the Q and the U. Normally we'll just branch forward one letter, like to the D or whatever, so then we'll get a QU. Okay, so let's do this. Oh, I know why. The terminator isn't set properly. So on the word tree, that's where our problem is. It's in the word tree. Okay, so we're going to send the index letter here, and here we're substringing. Okay. The word tree doesn't know about QUs. Okay, that's right. Maybe that's not it. The word tree does not know about QU parts. So this is right. So let's do a log here, and let's just figure out what the const okay. Const. I feel like I need to debug this. I keep saying debug it. All right, so let's do it for real. Let's do a debugging session. And I'm going to want to start here just to see what's going on. Let's debug for real, folks. Launch in a new window. Okay, okay, don't want to do that. Play. Back here, 2 players, start. Okay, let's just do a PO. Oh, I'm sorry, not yet. PO. Run. Go. PO. Alright, bother. Run. O and D. And submit it so it'll save our state. Okay, back to findwords. I want to stop here, and I want you to start on a QU somewhere here. Okay. Selected blocks, nope. Word spot is the parent spot. So now, and the block.letter.length is 2. And we're going to get to the branch. So word spot right now is a thing. So let's watch it here. Word spot. F10. All right. Wait, okay, word spot was not a thing. So let's look at word spot. Oh, we can't. Let's look at the parent spot. So the parent spot's letter is nothing, but there is a branch. And there is a branch for Q, which is supposedly where we went. So let's start over on that one. Unselect it, select. Okay, so I'm going to go down the branch here. So F10, do F11, F letter, F11. Okay, so the letter is Q. And so we have branches, right? There's 26 of them. There is a Q in there. It is a word tree. And the letter is Q. So F10. Now the word spot is there. Okay. F11. 11. Okay. The letter is U. And it's a little one. That's the problem. That's the problem. Okay, so it's a, we didn't get the uppercase U. So, dot to uppercase. There we go. That's our problem. So, stop. We don't need that anymore. Come back here. Find our QU here. Uncheck. Check. There it is. Worked. Wow, look at all those QU words. And if we click nearby the QU, it should find like QU words inside of it. Maybe. Yes, peek. Okay, great. That fixed the QU problem. So we come back here and okay, so we fixed the serialization there. That was a simple fix for the QU, remarkably simple, and fixed the vector2 there. Okay, so fixed QU word find issue and vector2 serialization. Okay. Okay, we are now successfully finding the words. Now we need to send back to the client the words that we have found. So back up here, we're not going to do this, and we're not going to do start time or end time because it's clearly fast enough. Now we're going to send a message. This.session is there a send to player. Send to player. player ID, comma, new play. Oh, this is a lexible message. Let's make it look like a failed word message, but it's not going to be a failed word. It's going to be a word hint message. Word hint. And so now we're going to go to our messages and we're going to make up a new message. So let's look at our failed word message. Excellent. All right, so let's, in the keeping of our refactoring, let's just keep refactoring these message classes. Failed word message data. Failed word message data, so it inherits from that. The payload is that type. Excellent. Okay. And then this goes up here. There we go. So that's the failed. I don't think we need to do that anymore. Okay. So that's what a properly set up message looks like. All right. So instead of a failed word message, we're doing a word hint. So let's just replace word hint here. Failed word, Control H, word hint, replace, do. Okay, so we got a word hint. So we have a word list string array. There we go. No letters. That's it. Okay, that sounds good. So if I save that and look back at the presenter model, it won't know what that is. We've got to include it, and we have to pass a payload to it, which is a flexible presenter message data, which is a word. Let's go to definition. It is, oh, it is a word list. So word hint word list. There we go. That's it. Okay, now the client will get it. So the client model needs to have a okay, it needs to keep track of the word list. So here on the client model, we'll just have an observable word list, which is a string array. Okay. And it's going to be undefined to start with. That's okay. Actually, we could just do this. Just make it simpler. And we want to add a listener to a lexible word hint message. And we want to handle a word hint message. Let's go to here and make it look the same. So handle word hint message. And this is going to be a word hint. And all right, in the message, we are going to say this dot word hint, word list is equal to the message dot word list. Boom. Okay, now we need to get rid of the word list when we deselect the word. So there's a select, set the block handlers, yeah. If index is greater than -1. Okay, and then we say if this dot letter chain dot length is equal to zero, then this dot word list is equal to nothing. So these should be actions. Because we're messing around with state and mobx, all this stuff should be inside an action. Do, and this send needs to, so I've got the coordinates from the block, which is passed in here, and the player ID doesn't change. The selected value is selected, is passed in there, and is first, but we don't want to save the checkpoint, so we'll go ahead and put that all in the action. There we go. Okay. All right, now we just need to show it on the client when that changes. So in the client view, so here we have this empty space in the client. So when we're playing, we're going to do it on the game screen. So in the game screen, game screen, where were we? Game screen render. It's going to render so the selected letters and do that. And then we'll show a submit button. And then we'll show here a div which has app model dot word list dot map. Okay, and we're going to map each word to a div with a key, which is equal to the word, and we'll put in it the word. And this should have a class name, which is going to be equal to the styles dot hint word, and this guy should have a class name called is equal to styles dot hint list. Okay, so now we want to put those in there. And okay, so game client dot game client dot dot hint list, and we'll just set the background equal to red for now, and then we'll have a no. Okay, and then similar kind of thing for the hint word, except the background is going to be yellow. All right, save. Okay, refresh. And let's unselect and select an N. There we go. So now we're seeing the list. I think the words, the font should be a little tinier. So let's set the font size here. Font size. Actually, we should just do this on the hint word. Let's see what happens when we do it up here. So if I do like 10 pixels, too tiny. So let's do 80%. That's better. So now we're going to have a list of words. The hint words, we want to have a little bit of margin. Let's do like 10 pixels. Separate them out a little bit. And we need to do a flex display, which is flex. Should make them wrap, yes. The overflow should be wrapped. Oh, I know it's got to be something. Let's see. CSS, flex, wrap, items, flex wrap, CSS tricks, flex wrap. All right, fine. Flex wrap, wrap, save. Nope. I want something like this, so Okay. Flex wrap items flow off the edge. Why are my flex items wrapping off the screen? Because don't use percentages on flex item margins. I don't think I'm doing that. Flex wrap items not wrapping. How about that? Not wrapping. Oh, I have an idea. Maybe the width. Let's do like 800 pixels. Does that change it? No. What if we just did 100 pixels? Is this even updating? Okay. I hate it when that happens. Back to 800. Okay, now it's working. Okay. Sometimes that happens. Like like you make usually when you do a syntax error in this. Okay, and then we want to align items center. Does that work? No, it's like flex align. Maybe flex align. No. Justify content center. That's better. Okay. Excellent. So now we can take off these backgrounds. Save. Excellent. So we can see a whole bunch of words there. I don't know if we really want to wrap all the way down, but it's showing the big ones. And well, everybody will have access to them. I'm doing play testing today, so who cares if they have like big giant words? It's just how it is. Yes, I shall just leave it like that. Okay, so I think we got the hints all the way done. I think this is going to count as good enough for play testing. So let's see if we left some turds and then we'll check in. All right, so we added this thing to display words on the, and we styled it. And then we added a new message that we send now when we get our words. On the client, we're handling, oh, wait, this is the new message type. And then on the client, we're handling messages coming in. We added a listener for it. We added a word list. We're handling the word hint messages and all that. Wow, that looks clean. All right, lexible, show word hints on the client. Oh, not so fast. What happens when I unselect N? It goes away. Fantastic. S, new words. So let's do sons, submit, and it unselects it. Yes, perfect. And then we come over here and we'll do like a V, VOTERS. Oh, this is so much easier to play when you have words to cheat with. Okay, done. All right, done for today. Thanks for watching. That was fun. Catch you later. Have fun coding.